Let's solve a tricky question on elasticity of demand. The question is, the demand function Q1 is equal to 50 minus P1 intersects another linear demand function Q2 at P is equal to 10. The elasticity of demand for Q2 is 6 times larger than that of Q1 at that point. We have to find out the demand function for Q2. Okay, so what we are being given? We are being given that is Q1 is equal to 50 minus P1. This is a linear demand function, and if I draw the graph here, so we have downward sloping demand function. Let us say we have Q1, Q output on the horizontal axis, price on the vertical axis. Since this is linear demand function, let's draw it like this. Let us say this is the demand function Q1. Okay, and we are being told this demand function intersects another linear demand function Q2 at P is equal to 10. So let's draw another linear demand function like this. Let us say this is Q2, this is another demand function. They intersect with each other at P is equal to 10. Okay, so let us say we have P is equal to 10 here. At this point, they both intersect with each other. Okay, so Q1 is equal to 50 minus P1. We are being told they intersect at when P is equal to 10. When P is equal to 10, that means when P1, which is equal to P1. Okay, so when P is equal to 10 in this equation, so what will be Q1? Q1 will be equal to 50 minus P1 is 10. That means quantity demanded when price is equal to 10 comes out to be 40. Okay, so at this point, since these two demand functions intersect each other at this point, which implies Q1 is equal to 40, and in fact Q2 will be also equal to 40. Quantity demanded when price is equal to 10 is equal to 40 units for both demand functions Q1 and Q2, since they intersect with each other. That is being given us here. Okay, now we are also being given that we are being told that the elasticity of demand for Q2 is 6 times larger than that of Q1 at that point when P is equal to 10. Let's denote, that means the elasticity of Q2, let's denote it by E2. We are being told it is 6 times greater than the elasticity of demand for Q1. Okay, so elasticity E2 is equal to 6 times E1, or let's use the proper color here. E1 is 6 times. Okay, so 6 times E1 here. Now we know that elasticity of demand for Q2 will be equal to, or let's draw it here, or let's write the elasticity formula. That will be equal to the change in the quantity demanded of Q2 due to the change in the price into P upon Q2. Okay, let's write it here P2 and here also P2, and it is equal to 6 times the elasticity of demand for Q1. That will be equal to, E1 will be equal to the change in the quantity demanded of good Q1 due to the change in the price of good 1 times P1 upon Q1. Here we are being told that the elasticity of demand for Q2 is 6 times larger than that of Q1 at that point. At that point means when price is equal to 2. So in both the places I can write, since we know that, and it is being given that at this point P is equal to P1 is equal to P2, which is equal to 10. Okay, so can I write here again this formula, that is dQ2 upon dP. In place of P2 I write P only into P upon Q2 is equal to 6 times dq 1 upon dp into p upon q1. Okay, and we also know that when p is equal to 10, q1 is equal to q2 is equal to 40, which we got it here. Okay, we also know that very thing. So we have dq upon dp, dq2 upon dp. So let's write it here, dq2 upon dp into what is p? P is equal to 10 divided by q2 is equal to 40, should be equal to 6 times. Okay, 6 times what is dq1 upon dp? That means the derivative of this demand function with respect to p1 here. Okay, so derivative of p1 will be 1 here, we are left with minus 1. So we have minus 1 times p, again p is 10, so we have 10 upon q1 is again 40. Okay, here 10 upon 40 gets cancelled on both sides, which gives us dq2 upon dp is equal to minus 6. Okay, can we do one thing? That means dq2 is equal to transposing this dp, it will get multiplied 6 times dp. Okay, now we integrate both sides, that the integral of dq2 should be equal to the integral of minus 6 dp. Okay, we take integral on both sides. Solving further, so solving it further, okay, let me use this color here. Now what is the integral of dq2? So the integral of dq2 will be equal to q2 plus the constant of integration, let us say c1, which will be equal to minus 6 times the integral of dp is simply p, plus we add the constant of integration, let us say c2. Okay, from the, you know, if we have the integral of dx, its integral comes out to be x plus c. Okay, this is from the simple integral rules. Okay, can we write it like this? And we also know p is equal to 10. Okay, so can we write it like this? q2 is equal to, or let us write it like this, q2, what will we do here? Okay, let's write q2 will be equal to minus 6 times p plus c2 minus c1, transposing this. Okay, we get this very result here. Or we can write, if I have the space, q2 will be equal to, rather we know that q2 is equal to 40, so in place of q2 let's write it here, 40 is equal to minus 6, p is 10, we know that very stuff, plus c2 minus c1. Okay, which implies c2 minus c1 will be equal to, transposing this, we have minus 6 into 10 is minus 60, transposing it here it will, or let us do it here, it will become plus 60, which implies c2 minus c1 is equal to 100. Okay, so we got the value of c2 minus c1 is equal to 100. So what is then the demand function for q2? So q2 will be equal to, so we plug the value of c2 minus c1 in this equation, so c2 minus c1, it came out to be 100, then we have minus 6p, that will be the demand function for q2. I hope I make myself clear in this video. Thank you.